Getting more confident? Let's get to do another one more sum. We get it right. Ooh la la, you can say you can be a master of graphs for high school, right up to about age 16 in Singapore schools. I don't know if you're abroad what it's like. But we're giving you a little challenging sum and have that sense of achievement when you get it right. Now let's look at it. As I said to you, in graphs, we are doing by approximation, nearly there, the answers. We look at this graph and we say, hey, you've got an x squared and the x is below. Right now, you can recognize it's definitely not going to be a parabola. But you also saw minus x squared. When it's minus x squared, it's a what? A peak. It's a frown. But in this case, this frown is going to be pulled by this. So it's not going to be symmetrical. The shape can be like that, or it can be like that, and it moves downwards. Right? Do you see it? So let's look at it and move on and understand the nature of this graph. Now all these readings are given to you when x, only thing when x is 12. A, what is y? Y here is A. Put in the value, hey, Mr. Y, you are A, first part A, y is A, 12 minus x squared, x is 12, 12 squared over 10 minus 48, 5 times 12, alright, because x is 12. When you put it in, you get a 12 minus 144 divided by 10. As I said, stay away from the calculator if you can. 48 divided by 60, you can see that 48 divided by 12 is 4. 60 divided by 12 is a 5. You can see you can cancel this off, 48 and 12, you get 4 over 5, which is a minus 0.8. Now taking this 12 minus 14.4 and minus 0.8, you can see A to be equal to, right? You get minus 2.4 there and a minus 0.8. Minus 2.4 minus 0.8 will give you a minus 3.2. Got it? Good. Next, you're going to use your graph, but before that, you're going to draw the graph using the scale of 1 cm for both units, for both 1 unit of each of them. Just look at your graph paper, see how you can scale it. Now, the highest point of the graph is here, 8. The lowest point is your A, which is equal to minus 3.2. That's your lowest point. Your y-axis is going to stretch from A to minus 3.2. Alright, we're going to draw the graph first, and then we're going to find the value of x when y is 4. I know you're moving faster right now. When x is 1, y is 2.3, approximately here. When x is 1. When x is 2, y is 6.8. 6.8, somewhere there. When x is 3, y is 7.9, near to 8. When x is 4, y is 8. Yeah. When x is 6, hey, when x is 4, y is 8. When x is 6, all right, we're going to get a gap there. We're going to leave it out 5. When x is 6, y is 6.8, near there, right? Okay, and when x is 8, y is 4.4. Look at 4, 4.4 somewhere here, all right? We can get it there. And when x is 9, 10, oh, x is 10, y is 1. 1 is there. When x is 12, y is a minus 3.6. 3.6 somewhere here, move down. That's what you get. Now we were able to picture it earlier on, right? We said it's a frown. And let's see how far away it is. Move, draw with a steady hand. Doop, 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 doop. Ooh, we're gonna get right down. Look at that. We go right down. Saw the frown? See it? It's not symmetrical. Draw the line of symmetry. Doop. It's not a quadratic. It's not a parabola. Get an understanding of polynomial equations. They all fall under that category. Whether it's a quadratic, it's all polynomial. When x is 1, the power is 1. The highest power, you call it a linear equation. When x is 2, and we know what's quadratic. When x is 3, is cubic. When it has got all these mixed together, we call it in Singapore English, rojak. You got an x squared, you got a 1 over x mixed together. A common name will be a beautiful name. Polynomial equations. Alright, that's the common name. As I said, we always got to label the x's, my dear, and write the name of this equation. You are 12. X squared over 10 minus 48 over 5x. We now come to the next part. We said, hey, find the solution of this. And we look at this, hey, where you came from. Look at it. And we said, are you related to that? And we look at this, we get 96 over x. When I absorb the minus 1/10 in, all right, we can see perhaps some things happening. Let's find out. All right, so the part D is going to be where the challenge is, and hope you can follow me, and if you have done it, very good. Now they say that x is equal to minus 1/10. All right, this is what we're given. I'm going to write it out so you can follow me through. Plus x squared minus 120. Now let's absorb that in. 1/10 divided, you get a minus 96 upon 10x. Right? When you put that in, you get a minus x squared over a 10. Absorb that in, you've got a 12. 120 divided by 10. A minus and minus would give us a plus. Now put that in and we said, hey, this is coming somewhere near there. Look at this 12 and I see a 12 there. I'm glad. I look at this minus x squared over 10. Ooh la la, I see that. And I said, ooh, if I divide up and down by 2, I get a 48 over a 5x. Say, look at it. This has been simplified to your y. This is y. And so I said, don't panic. In maths, we must be one thing very sure about it. Never panic when you see something. It's just that they're trying to pull wool over your eyes. Right? The person who's asking you these questions, making it a bit tricky, you're just being cheeky, you tell yourself, and get to it and see the relationship. And he said, oi, hello, you're y. That's y, and y is equal to x. That's what they want you to draw. This is y, and y is equal to x. And is that a chore for you? Alright, you can draw it. Well, it's a straight line. It's passing through 0. The gradient is a 1. When x is 1, y is 1. Alright, simple straight line, but it's 2. You got to stretch it. When x is 6, y is 6. We said, hey you, there you are. And we just draw this straight line across. I missed it. Well, just say this is the line. Draw it out. Y is equal to x. Right, you've got it. And now use your human eye to read it. Use a calculator to check it. And then adjust your human eye. Sometimes parallax errors occur. right? So your solution will be when they meet here and you said, oops, they meet there. And that's your answer. You said, hey, this thing happens when x is slightly above 6, maybe 6.2, right? When x is 6.2, they want to find the solution. They're not asking you for y. They're asking you this is expressed in x. What is asked, you give. What is not asked, please do not be too generous, because sometimes it's read as you did not read it right. So you were asked here, what is x? So your answer here, x is 6.2. You can see when x is 6.2, y is about there 6.2, and similarly on this graph too, you can see it because y is equal to x. That's your answer. Alright? Next part, we are asked to find the gradient when x is 4, y is 8. What is the gradient? Alright, the gradient is the slope. When x is 4, y is 8. When x is 4, y is 8. And the gradient is here. Got it? Looks like almost a turning point like that. Alright, nearly flat. If it's flat, then that's the turning point, the peak. Either it's the maximum or the minimum. This is just about there. Alright, when x is 4, y is 8. From my graph, it looks like a negative gradient. But what about your graph? Is it about there? Alright, just check it out. Alright, so just take 2 points, as I said, very distinctly. Alright, to find the gradient at this point. When x, take a point which is easy to read. When x is 2, draw it up roughly here. When x is 2, what is y? Somewhere around here, that's 9. So this will be about, I would say 8.2. Alright, and take another point here, maybe when x is 7. When x is 7, what is y? Look at it here, it's about 7.5, right? So the last part of the sum, E, at the point 4, 8, at 4, 8, the gradient will be, take your equation y1 minus y2 over x1 minus x2. That's your y, 7.5 minus 8.2, or you can say 8.2 minus 7.5. I'll leave it to you, but remember, if you start from there, you go back to your x from there. 7.5 minus 8.2. Got it? And then your x, we started here. X is 7, y is 2. So when you take away here 7.5 minus 8.2, you get a minus 0.7 divided by a 5. So we can see it's a small gradual slope, and when we divide it by 5, we get the gradient to be a minus, well, you get a 0.14. That's your slope. You got it? Near there? About there? Fine. Well, my dear, you're becoming gradually and surely and certainly you're getting better and better, I believe, in your graphs.